Hey everyone, it's Justin again. One of the best ways of solving inequalities is by graphing them. So that's exactly what we'll be learning about in this video. As with checking solutions, doing most things with inequalities will be almost exactly the same as with equations, but with small twists. The same can be said for graphing. So before we try graphing this inequality, let's graph it as if it was just an equation. This is in slope-intercept form with a y-intercept of 1 and a slope of 2. This is how we would graph it if y was equal to 2x plus 1, except it's not. Y is less than or equal to 2x plus 1. This is where inequalities have a little twist. One side of this line, either above it or below it, will contain all the solutions to the inequality, and we need to know which way the shading needs to go. To figure this out, we simply test a point on either side of the line. Typically, we want to test the point 0, 0 if possible, because it's usually really easy. If 0, 0 is a correct solution, then all the solutions will lay on the side including 0, 0. But if the point doesn't work, then all of the solutions are on the other side of the line. So let's test 0, 0 and see if it's on the side with the solutions or not. We replace x and y with 0, and 2 times 0 zeroes out and disappears, so we get the statement that 0 is less than or equal to 1. This is a true statement, so our test point was on the correct side, which means we shade in that side of the line to show that this is where all of our solutions are. So now we know the first thing we have to do is graph the inequality like it's a regular equation. In this case, it's in standard form. So we ignore the x term and get that the y-intercept is 4. Then ignore the y term and solve for x, giving us an x-intercept of 2. And we just draw the line through them. But remember, this didn't start out as an equation, it started out as an inequality. So we're not done yet. The points directly on a line are the points that make both sides of the equation equal. However, this inequality says the left has to be strictly greater than the right, not equal to it. So how can we show on the graph that the line itself can't be used as a solution? We use a dashed line for inequalities without the or equal to part to show that the points on the line are not solutions. Now we just need to know what side to shade, so let's test the point 0, 0. Plug in 0 for x and y, and simplify. Is it true that 0 is greater than 4? No, that's false, which means 0, 0 is not on the side with the solutions. The side with the solutions is this side here. Do you think you have it? Let's do one more example. First, we need to graph this like we would an equation. It's in point-slope form, so we graph the point -2, 1, then use a slope of -1/2 to draw the line. Should the line be solid or dashed? Since the inequality is strictly less than, not equal to, the line should be dashed to show that the points on the line are not part of the solution. Finally, we need to test a point, but 0, 0 isn't on one side or the other, it's on the line. Since testing that point won't tell us which side is correct, we'll need to test some other point. So let's go with 2, 2. Plug in 2 for x and y, then simplify both sides. Did the result come out true? No. So our test point is on the wrong side of the line. The side with all of the solutions is underneath the line. Graphing inequalities takes what we already know of graphing and adds a couple new pieces, whether the line is solid or dashed, and testing points to decide which side to shade on. In the next video, we're going to use graphs of inequalities to decide whether solutions work or not. No algebra necessary.